Hey there, space cadets. Have you ever looked up at a rocket launching into space and wondered, how did we ever figure that out? Well, it turns out the story of rockets is a long and exciting one, going way back in time. We're talking centuries ago. Think about ancient civilizations like the Chinese. They were already experimenting with rockets in the form of fire arrows over 1,000 years ago. These were basically arrows with a tube attached filled with gunpowder. When ignited, whoosh, off they'd fly. While not rockets as we know them today, these fire arrows demonstrated the basic principle that a controlled explosion could create thrust and send something flying. The idea of using this power to actually travel to the stars, though, remained a fantastic dream for centuries. People just didn't have the scientific understanding or the technology to make it happen. But the seeds of rocketry had been planted, and they were slowly beginning to sprout. Now let's fast forward a bit and explore some of the key discoveries that helped turn those flying dreams into reality. Fast forward a few centuries and we find ourselves in the Renaissance, a time of incredible scientific discovery. It was during this period that folks started to really understand the laws of motion and gravity. That's right, we're talking about Isaac Newton and his famous apple. Understanding gravity, that force that keeps us grounded, was crucial for figuring out how to overcome it. Scientists began to experiment with different types of propellants, looking for ways to create enough power to launch objects high into the air. They tried everything from gunpowder to steam, constantly refining their designs and learning from their mistakes. One major breakthrough came with the development of solid fuel rockets. These rockets used a mixture of fuel and oxidizer, something that helps the fuel burn in a solid form. This made them more stable and easier to control than earlier designs. With each new experiment, we were getting closer and closer to the stars. The stage was set for some truly brilliant minds to take these early discoveries and launch us into the space age. Now let's meet some of the rock stars of rocket science. These brilliant minds took those early ideas and turned them into real working rockets. First up, we have Konstantin Tsiolkovsky, a Russian school teacher with his head in the clouds. He'd figured out the math behind rocket science, proving that liquid fuels were the key to reaching outer space. Next, we have Robert Goddard, an American physicist who wasn't afraid to get his hands dirty. He built and launched the world's first liquid-fueled rocket in 1926. Talk about a game changer. And finally, we can't forget Wernher von Braun, a German engineer who helped develop the powerful V-2 rocket during World War II. While his work had a dark side, von Braun later played a crucial role in the American space program, leading the team that built the Saturn V rocket, the one that took us to the moon. These pioneers pushed the boundaries of what was possible, paving the way for the incredible achievements in rocketry we see today. Okay, so we've talked about the history of rockets, but how do they actually work? The basic idea is pretty simple. Rockets use the power of controlled explosions to create thrust, which is a fancy word for a pushing force. Imagine blowing up a balloon and then letting it go. The air rushing out creates thrust, propelling the balloon forward. Rockets work in a similar way, but instead of air, they use a mixture of fuel and an oxidizer. The fuel provides the energy and the oxidizer helps the fuel burn. When these two mix and ignite in the rocket's engine, they create a powerful explosion that produces hot gas. This gas is then channeled through a special nozzle at the bottom of the rocket. The nozzle is shaped like a bell, and as the hot gas is forced through this narrow opening, it expands and speeds up. This creates thrust in the opposite direction, propelling the rocket upwards. It's all thanks to Isaac Newton's third law of motion. For every action, there is an equal and opposite reaction. Please subscribe to our channel for more exciting content on space and rockets.